Dear students, class 10, let's recall. We discussed zero polynomial and zero of a polynomial. Today let's discuss zeros and coefficient of a polynomial and their relationship. It is an important topic in your mathematics chapter polynomial. So look at this side. The standard form of a linear polynomial is ax plus b, and here a is the coefficient of x is not equal to 0. If it becomes 0, then the term will be a zero polynomial. Okay. So the condition is here, a is not equal to 0. Now look at, let the polynomial px be 0. So we can write implies ax plus b is equal to 0. By transposition, ax is equal to minus b and x is equal to minus b by a. And x is the 0 of the polynomial. And a linear polynomial has only one 0 that we have already discussed. Then what is b and what is a? Minus b by a. Now you see, minus b is a constant term, that is b. Constant term means a constant polynomial. And a is the coefficient of ax. And you see, in a linear polynomial, the degree of the variable is 1. That we have already discussed. Now come to the second part. That is the standard form of a quadratic polynomial. Now you see, the standard form is ax square plus bx plus c. And the condition is a is not equal to 0. Why it is quadratic? Because the highest degree of the variable is 2. That we have already discussed. So let's take an example from your textbook. So 3x square plus 5x minus 2, that is in form of a quadratic polynomial. Let px, this polynomial, is 0 for any value of x. So let px is equal to 3x square plus 5x minus 2. And you have already learnt in class 9, by splitting the middle term, we can write 3x square plus 6x minus x minus 2 equals 0. Why? Now you see, the product of the first term and the constant will be the product of the first term and the second and the constant is 6 minus 6x square. Okay. Now you see, the middle terms, their product is minus 6x square. And their sum of two middle terms, now you see 5x. So that procedure, that stage you have already learned in class 9. So that implies, by taking common 3x, we get x plus 2, and taking common minus x, we get x plus 2 equals 0. And taking common x plus 2, the expression x plus 2, we get x plus 2 into 3x minus 1 is equal to 0. The product of two expressions is 0. And we can say either this expression is 0 or this expression is 0. If x plus 2 is equal to 0, x is equal to minus 2. So this polynomial is 0 at x at minus 2. So here minus 2 is 1 0 of the polynomial. And if you consider the second case, 3x minus 1 equals 0, so x is 1 by 3. So the polynomial is 0, x at 1 by 3. So 1 by 3 is another 0 of the polynomial. So what we conclude? We conclude in a quadratic polynomial, generally there are two zeros. But quadratic polynomials have also only 1 0 and no 0, that we have already discussed. But in this class, or in this, generally we shall discuss a quadratic polynomial having two zeros. Now, let us actually find out sum of two zeros. Now we got two zeros, minus 2 and 1 by 3. The sum of two zeros, 1 by 3 plus within bracket minus 2. So the result is minus 5 by 3. Now compare with the polynomial. Here is the polynomial. This is minus 5. 5 is the b. You see b is the coefficient of x. So minus b by a. A 3. 3 is the coefficient of x square. Now clear? Product of two terms. Product of two zeros. Now we have got two zeros. 1 by 3 into minus 2. So what you get? The result is minus 2 by 3. Let us compare. Minus 2 is the constant term and minus 2 is the constant term and a is the coefficient of x square. So the sum of two zeros is minus b by a and the product of two zeros is c by a. Now we have given some tricks to understand the k is a constant and let k be any real number other than 0. So you please try taking the value of k as 2, 3, minus 2 or minus 3 or root 3 etc. So if you multiply so this quadratic polynomial by 2, minus 2, 3, root 3, you please actually do it at home. You please find out whether the zeros are affected or not, or zeros are changed or not. There will be no change. And this question was asked in this exam. What is the value of k? The value of k is infinite. So what are these polynomials? These polynomials we can say these are equivalent polynomials. So the zeros will not be affected. And this question was exclusively asked in CBSE exam, perhaps in 2023. So come to our general explanation. So general expression of a quadratic polynomial. So standard form we have discussed here, ax square plus bx plus c. So a is the coefficient of x square, b is the coefficient of x, and c is the constant term. And condition a is not equal to 0. So here some students ask questions why a is not equal to 0. If a is 0, this term, the first term, becomes zero polynomial. Now the quadratic polynomial is converted into a linear polynomial, bx plus c. Anyway, so now we got two zeros of a quadratic polynomial. Let one zero as alpha and another zero as beta. These are Greek terms, never be confused. So we can say x is equal to alpha implies by transposition x minus alpha is equal to 0. And if x is equal to beta, so x minus beta is equal to 0. Simply you can say if x is equal to minus 2, then x plus 2 will be 0. And if x is equal to now 1 by 3, so x minus 1 by 3 will be 0. So these are examples that we have derived here. So here x minus alpha is 0 and x minus beta is 0. There are two expressions. Now the product of the two expressions is 0. So we can write ax square plus bx plus c, the quadratic polynomial, is equal to the product of two zeros. So x minus alpha into x minus beta. Okay. So let's multiply k here. The reason is why. The reason is why? Because here A is not always 1. It may be any real number. For that reason, K is multiplied here. Many students ask this question, why K is multiplied? If we don't multiply the K, we shall get this portion, x square minus x into alpha plus beta plus alpha and beta. And here the coefficient of x square will be 1. But generally, the coefficient of x square is not always 1. It may be 2, it may be 3, it may be any real number, minus 2, minus 3, minus 5, or root 2, etc. So, to generalize the expression, k is multiplied. So, we have mentioned here, hence k is multiplied. So, now you multiply it. So, x into x square, x into minus alpha, x into minus x alpha, here minus x beta, x alpha, and minus alpha into minus beta, that is plus alpha into beta. That is very simple. Now you multiply with each term. So after multiplication we get kx square minus k into alpha plus beta into x, the k alpha into beta. So now the trick is, here we got the form of quadratic polynomial. Now look at ax square. Here a is k, means k is the coefficient of x square. And now x, here x, the total, this expression is called b, the coefficient of x. So we have written here b is equal to k into alpha plus beta. Now c, the total c is k into alpha plus beta. So this expression is in the form of ax square plus bx plus c. Okay. Now come to the very simple and very interesting. A is equal to k, that is let it equation 1. B, k into alpha plus beta equation 2. C, k into alpha, k alpha into beta equation 3. So let's take equation number 2. In equation number 2, we find b is equal to minus k into alpha plus beta. So keep it by transposition, alpha plus beta in RHS. So now you transpose it. So we get my b by minus k into alpha plus beta. So simply we can write alpha plus beta is equal to minus b by a. By a. Now you see in the equation 1, a is equal to k. So a is equal to k. So in place of k, we can write a. So in place of that is minus b by k. Minus b by k. But k is equal to a. So we can write minus b by a. Here we got minus b by a. Now it is proved. Then the product of two zeros, alpha, the product of two zeros, we can find out. Let's see. In equation number equation number 3, c is equal to k into alpha and beta. K into alpha into beta. So alpha into beta is the product of two zeros. So by transposition that will be c by k. But that will be c by a, because as a is equal to k. Here a is equal to k. Now proved. So we got the conclusion. The sum of two zeros is minus b by a. What is minus b? That b is the coefficient of x and a is the coefficient of x square. So the product of two zeros, that is c by a. C is the constant term and a is the coefficient of x square. Oh, and here just actually remember, the value of k is a real number other than 0. It is infinite, and this question was asked in CBSE exam and in other board exams. So this is the general expression you have to remember, and this is the splitting of middle term how to find out zeros. And this is the general expression of a quadratic polynomial having two zeros. Hope you have understood the topic. Stay tuned to watch our next video.